Hello and welcome back to another course. In this chapter we will discuss about impedance and reactance, something that you will use and hear all the time in electronics. I guess I don't have to tell you about the importance of this chapter, so just pay attention, and if you want to ask anything, just leave a comment under the video. Alright, so let's begin, and the first question is, what is impedance? Well, impedance is a measure of the overall opposition of a circuit to current. In other words, how much the circuit impedes the flow of charge. It is like resistance, but it also takes into account the effects of capacitance and inductance. Impedance is measured in ohms. Impedance is more complex than resistance because the effects of capacitance and inductance vary with the frequency of the current passing through the circuit, and this means impedance varies with frequency. The effect of resistance is constant regardless of frequency. So both resistance and impedance are measured in ohms, but resistance doesn't vary with the frequency of the current passing through the circuit, as opposed to the impedance, which, because it takes into account the capacitance and inductance, it does vary with the frequency. Now, impedance can be split into two parts, resistance R and reactance X. The first part, which is resistance R, is the part which is constant regardless of frequency, and the second part, which is reactance X, is the part which varies with frequency due to capacitance and inductance. The capacitance and inductance cause a phase shift between the current and voltage, which means that the resistance and reactance cannot be simply added up to give impedance. Instead, they must be added as vectors, with reactance at right angles to resistance as shown in this diagram here. As you can see, this is the formula that you have to remember in order to calculate the impedance, and this is how you calculate the reactance. The next course will be about reactance, and you will understand how capacitance, inductance, and frequency affect impedance. But before that, you might ask, what does phase shift mean? In purely resistive circuits, the current and voltage both change in the same way and at the same time. This relationship is true whether the applied voltage is direct or alternating. Phase shift means that the current and voltage are out of step with each other. Think of charging a capacitor. When the voltage across the capacitor is zero, the current is at a maximum. When the capacitor has charged and the voltage is at a maximum, the current is at a minimum. The charging and discharging occur continually with AC, and the current reaches its maximum shortly before the voltage reaches its maximum, so we say the current leads the voltage. Note that an inductance also causes a phase shift between voltage and current, but in a different way than a capacitor. Inductance opposes change in current due to the back EMF effect, and this causes the current to reach its peak value sometime after the voltage. So in an inductive circuit, current lags voltage. You can notice this phase shift effect in our simulator by running an AC voltage through a capacitor or an inductor. The green signal is the voltage and the yellow one is the current. In a circuit containing both inductance and resistance, which is usually the case as the inductor, which is a coil of wire, will have some internal resistance, the current will lag the voltage by an amount between practically 0 degree and almost minus 90 degree. On the other hand, in a purely capacitive AC circuit, the amount of phase shift between voltage and current is plus 90 degree, with the current leading the voltage. The opposite phase shifts to an inductive circuit.